The Channel Tunnel terminal site at Cheriton and Dollonsmore has a complex overhead catenary system. Catenary simply meaning suspended overhead cables. This system is powered at 25,000 volts AC. Therefore, personnel must be aware of the potential dangers associated with this amount of voltage and have a detailed understanding of the on-site procedures regarding isolation and the precautions to adopt when working in the vicinity of these cables. I had the opportunity to speak with Eric Tim, the TML Overhead Catenary Manager, and ask him about the voltage that we could expect to find on site.
Well, what we've got is we've got 132 kV or 132,000 volts, which comes in from Sellenge onto this side of the substation, and then we go through transformers, which is placed along here, which then reduce the voltage down to 21 kV for the general utility services of the tunnel, and then we reduce it down to 25 kV for the overhead catenary feeders, which is these three feeders over here, which are the two tunnel ones, and the terminal feeder is that one over the other side there. Yeah.
So we're feeding the tunnels with 25,000 volts overhead catenary.
Yeah.
Say this system breaks down, Eric. Are we saying there's no shuttles will run through the
No, we
tunnels?
can reconfigure the system from the French side, so we can actually, at the midpoint, there is switchgear that we can actually close and supply UK tunnels and terminals from French terminals. That's what they call a downgraded mode.
Where do you control that from then?
That's controlled from the control centre, which is up at Sheraton there, which is the main control centre, and that can actually be done by what they call a SCADA system, which they just call up on the screen, identify the dead circuits, and then close the breakers from the control centre to re-energise. So the reconfiguration can be done fairly quick.
I see. Noticed on this particular site at the intake station here, there's a big switch room here of some significance. Briefly, what goes on in there then?
Basically, in that switch room is all the control and protection for every piece of equipment that's within this substation, which is then monitored back at the control centre via monitoring circuits.
How would you identify a particular area that you'd want to isolate then? We turn up as the fire brigade, we've gone to a specific area of the site, we need to identify, yes, we've got a problem here. What sort of information would you need? Yes, this is the area that needs isolated.
We'd need to know what, for the tunnels, for example, whether it's running tunnel north or running tunnel south, we need to know the changes of the isolation. So we can actually, when we operate a breaker here, we'll actually switch off the whole running tunnel north, or we can operate a breaker to switch the whole running tunnel south off. So we can actually isolate the whole of the tunnel to the midpoint with one operation from here. Terminals, we can isolate the whole terminal from one operation. If you specify a certain area that you want to work on, or if there's an incident in a certain area, we would then carry out an isolation of that area. So the first line would be to isolate the whole terminal, and then we would then go along and then would carry out an isolation of that area and then re-energise the rest of the terminal.
So you can actually isolate a specific section
We
of
can
it?
sectionalise it, yeah. So you have a main section and you have subsections. So we can then isolate a subsection.
So let's recap on what Eric said. We've got 132,000 volts coming onto site, 25,000 volts AC, powering the overhead catenary, and 21,000 volts for utility services around the site and underground. The system can be reconfigured to ensure an alternative supply from France in the event of an electrical breakdown on the UK side. The running tunnels can be totally isolated individually or in 1.2 kilometre sections. Also, a section of the site needs to be isolated only if necessary. Now perhaps is the time to explain in very brief terms how the catenary energises a shuttle. The power firstly starts off at its source, which is the main intake station at Cheriton. Through the catenary at 25,000 volts and is picked up from the pantograph on the shuttle. The power then drives the motor within the shuttle, and the return path is via the wheels, through the rail and back to its source. I spoke to Eric Tim again regarding isolation. Would you explain to us exactly what you do when a an isolation is requested on site?
Right. What we do on site is first of all, we would communicate with the electrical control centre and ask them to isolate the main supply. Once they've confirmed to us that the main supply is isolated for that section, we would then prove the line dead before we apply our earths. Before we open the isolators of that section, and then we would prove dead and apply the earths.
You said prove dead there, Eric. What do you mean by prove dead? How do you do that?
We do it with what they call a live line tester,
Yeah.
which is it detects any voltage within the system. So it will detect, this particular tester will test up to 33 kV or 33,000 volts. So if there's any voltage within the system, we would detect that before we carry out any operation like opening isolators or applying earths on the system.
You've got one of those live line testers here, Eric. Could you,
Yeah,
so we can recognise what one of these things does?
Right, what we've got is that which will fit on the end of our poles, so we could actually go up onto the catenary system. Basically what we do is you switch it on, which gives out a bleeping. We've got a test facility on it, which we prove and then gives a continuous signal. And then we have what they call a proving unit, which you hook onto the end of it, and it will simulate a voltage present. So that then, once you've done that, you would then go up onto the catenary. Yeah. If it's a continuous signal, you know there's voltage present. If it's a bleep, you know that the system is dead. So you're quite happy with then to carry on with the next stage of the isolation.
Okay, I understand that, Eric. So
Right.
we've got now what we consider an isolated line. It's a dead line.
Yeah.
What procedures then? Is that it then? I mean, we can now work on it, or is there other work?
Well, what we would do then is open the isolator, for that particular section, we would open the isolator at either end of the section. And if you see the section drawings, it will show you that each section can be isolated and independently isolated from the system. So we'd open the isolator at either end of that section or subsection. Once we've opened the isolators, we will then apply the duplicate earths at either end of that section, and then wherever your work site is within that section, we would then apply an earth either side of your work site. The reason for that is for any induced voltage that may come from the rest of the system, because if you're working on that particular section to do a function, so we don't disturb too much the normal running of the trains, we would then re-energise the rest of the system while you're working on that system. And obviously because you've got parallel lines running with the isolated section, there's a possibility of pickup. So the reason for putting the earths on is to stop any induced voltage within that.
Is it possible to put a figure on that, sort of residual current that's likely to be in that line, or is it?
It could be
many factors.
It could be many factors depending on what the parallel lines are. Here, because it's 25 kV parallel lines, probably it could be as much as 1 kV, 1,000 volts.
Yeah.
It's if you had a 132 system or 275 running parallel with it, you could get a lot more induced voltages.
So let's have a look to see the procedures for isolation and the earthing down of a section of overhead catenary. Of course, firstly, a request is made for a general isolation of the overhead catenary from the electrical control officer, after identifying with him the location of the section to be isolated. Once confirmation has been received, a test of the live conductor is carried out. The test you see here is confirmation that the power is off. The next step is to isolate the particular section wishing to be worked on. This can be done manually, or in most cases by electrically driven motors, either locally or remotely from the control centre. At the top of the post you see the isolating mechanism. This has a dual purpose, one to isolate a section and 2 to engage the rear pin to earth. However, as a further precaution, this is followed by fitting earth straps to the now confirmed isolated conductor. This action both ensures that any residual current remaining in the line is removed to earth and that the section of line is protected by any inadvertent re-energising by thrown out circuit breakers. The first important action is to make the earth connection, in this case to the metal post, which is permanently common to earth. Then by using fiberglass extending poles, the earth straps are connected to the conductor using specially adapted screw fittings to ensure a good connection. And finally, the locking off and labelling to indicate an authorised isolated section. A similar principle is adopted in the running tunnels. Eric Tim again.
Basically the same procedure there. Again, we would request an isolation from the electrical controller, make the system dead. He would then open the breaker in the main substation here. That would then isolate the whole tunnel from UK side up to the midpoint, whether it be north or south. And then we would then go down, if you wanted a particular area you wanted to work in, we would then go down and open the isolator either side of your worksite area. And we'd then again put the 2 earths up either end and then put the earths up around your work site. So the isolation would always be far greater than your actual work site you work in. So you could isolate, well, the isolation in the tunnel is approximately 1.2 kilometres each section. So the minimum isolation you would get there is 1.2 kilometres.
Just clarify something here. You break an isolator this end of the tunnels, the Gerald portals.
Yeah.
You understand that it isolates right through the tunnels.
Yeah.
Where do you get a feed from then if you want to sort of back feed onto that just to take out a 1.2 kilometre section?
We can back feed it from, we have various points. Say for example you isolated a section in Running Tunnel North. There are means of reconfiguring the rest of the tunnel. If you isolate a certain section, you could actually re-feed the tunnel, Running Tunnel North, from the South Tunnel using, there's cross-coupling circuit breakers within the tunnel which can actually feed it. There's one at the crossover and there's one at the midpoint. We can also feed it from France by closing the breaker at the midpoint.
So going back to the earthing again, these earthing straps, they're going to be with us throughout then. That'll always be the case that these cables need earthing down prior to anybody working on that section.
Yes, yeah. That's always, that's got to be, because it's your protection, it's protection against anybody closing a breaker or residual or, you know, induced voltages within the system, you know.
On the site there is an emergency siding with 2 sets of blast walls equipped with fixed overhead water or foam monitors. The catenary system runs between these blast walls and directly below these monitors. Isolation prior to use of these monitors is absolutely essential. Eric Tim again.
Either end of the emergency siding you've got an isolator. The one at the west end of it is a manual isolator which has to be opened. Once you open that, it earths it down automatically. And then at the east end of it, again, but that's an electrically operated isolator. it opens and earths down as well. So but the isolators on the emergency siding are either closed, giving 25 kV on the catenary, or opened and earthed, which earths down that particular part of the catenary.
Worthy of mention is Dollond's Moor, adjacent to the Cheriton terminal site, which is the area where the third rail system ends and the overhead catenary starts. Personnel should be aware of a potential situation of both overhead and underfoot electrical hazards in the Dollond's Moor area.
It's basically fed from the rail that runs through to Folkestone, so their feed would come from there. The other thing to bear in mind is because BR haven't got 25 kV or 25,000 volts feeding, we feed Dollond's Moor from here. So, I mean, that's a point of interest. Although Dollond's Moor of its British rail, the supply comes from this substation.
Another area of significance not yet mentioned are the overbridges, which are the 4 raised structures leading onto the loading and offloading platforms.
At the moment I'm standing on overbridge 1 at platform 8. You'll notice I'm surrounded here by overhead catenary. Firstly, there's plenty of clearance at this stage for fire appliances, and secondly, there may be concern that the cables going across these platforms are live from the 25,000 volts that feeds the overhead catenary system. That isn't the case. As you can see here, there's insulators on both sides of me to ensure that this platform section always remains isolated from 25,000 volts.
"25,000 volts electrical power is a high tension supply with a number of inherent dangers. These dangers can be removed if personnel follow these disciplined procedures when on site. Always assume the catenary is live unless confirmation has been received of its isolation. The normal safety distance is 3 metres from live equipment. However, this distance may be reduced for specific tasks. Personnel should never work above live catenary, even to using ladders on adjacent buildings, unless an isolation has taken place. Care in the removal of equipment from the tops of appliances, and vigilance even when carrying equipment around the site or within the tunnels. It is important that you have confidence in the on-site procedures regarding the overhead catenary system and the specialised staff who will isolate and earth the system to ensure your safety. Remembering the reasons for earth straps.
It would immediately bring out the protection, so if it protects the workmen within that area. So if somebody did close the breaker, it would prevent the guys getting electrocuted that's working within that area, because it would take it straight down to earth and bring out the main protection in the main substation.
Electricity is a very good servant. You can't see it, you can't smell it, but you can certainly feel it. And even this may be brief at 25,000 volts.